Alright, all you math savants. Yesterday we were talking about how to calculate the average atomic mass when working with naturally occurring isotopes. How do we find that average when we've got all these different types of atoms hanging out with different masses? So yesterday we did a little calculation, and the chemistry part was figuring out what the numbers meant and where to stick them. But once you had the numbers in, it just became algebra. You just had to run that calculator. Now today we're going to look at a slightly different type of problem. On our handout 3.2, go ahead and take a look at number 3 for me. Number 3 says europium has two naturally occurring isotopes, EU151 with a mass of 150.9196 U, and europium 153 with a mass of 152.9209 U. And then it tells us that the average atomic mass, the actual average of europium, of all these naturally occurring isotopes, is 151.96 U. And here's our question. Calculate the abundance of each of the europium isotopes. Ew. Well, that's a bummer. Well, we know that we've got the average, we know our two masses, so in this particular instance, we're actually trying to solve for the percent abundance. Now, if you remember from yesterday, the percent abundance has to equal 100%. All of the isotopes, all of the atoms in the world for a particular element have to equal 100%. Now, we didn't quite use 100% in our calculations yesterday. We got rid of the percent by turning it into decimal form. Well, 100% in decimal form is 1. So whatever we use for our abundance in our calculations now, we're going to have to do a little algebra, a little variable action here. Whatever we use, when added together, those two variables, those two percentages, must equal 1. So if we call our first variable x, sure, why not? X plus some other variable, sure, why not? Y. Our two variables, whatever we use for our two abundance in our calculation, when added together, must equal 1. Well, okay. Let's go ahead. Let's pretend we were solving for y then. Well, to get y by itself, we would subtract both sides by x to get y equaling 1 minus x. Aha! Well, now we can solve for one variable using one equation. So let's go ahead. If we call one of our variables x and our other variable 1 minus x, these two added together must equal 1. Well, do they? X plus 1 is x plus 1 minus x gives us 1. So what we're going to do is we're going to use these two for our 2% abundance in our calculation. All right, so we go back to our problem. Back over here on number 3. Europium 151 has a mass of 150.9196. Well, all right, so we got our first percent. We're going to go ahead and call it x. We're going to take that times, using our formula from yesterday, our abundance times the mass, in this case 150.9196. And we're going to add to that our second abundance, in this case 1 minus x, times its mass, which from the problem was 152.9209. Now those two added together must equal our average, which from our problem they told us was 151.96. So all we've done is, using substitution, we've set both of our missing pieces to one variable. We've substituted those in for the missing percentages, and now it's become algebra. All we need to do now is solve for x. Well, a number times x is that number x. And that's going to be added to, we need to distribute here. We're going to have this number times 1 subtracted by this number x. So 152 times 1 is 152.9209. That number times a negative x gives us negative 152.9209x. And that is all still equal to our original average of 151.96. Well, now we can go ahead, we can combine our like terms on the right-hand side. We can subtract over this value from the left-hand side, and then we would just have to solve for our x value. So anytime we have to solve for abundance, we're just going to use the values x and 1 minus x. This works every time. Now this only works if we are actually using a 2% calculation. If we get into those 3 isotopes, it doesn't quite work right. But we can follow this same process of plugging in x and 1 minus x for any of these problems where we have to solve for abundance. I will not ever ask you to solve for 3 different percentages. Cool. So go ahead and finish up this calculation for me. Be sure to, when you solve, you're going to solve for an x value, and then you will have to go back and solve for that other piece, that 1 minus x. Remember, they want the percents. So the very last thing you will have to do is multiply them back by that 100. Awesome. Give it a shot. See how you do.